Smell is composed of particular molecules. When we breathe, the volatile compounds released by the objective will be received by our noses. A signal will be generated and transferred to the brain. The brain will process and identify the signal. Then we can know what the smell is. Therefore, the process of smell basically includes 3 steps: signal generation, signal transmission, and signal processing. The electronic nose works in the same principles as human sense of smell. The fundamental part of the electronic nose is the gas sensor. The volatile compounds contact with the gas sensor. The electronic signal will be generated and transferred to the computer. After the signal was analyzed, the computer can identify what compounds they are. Electronic nose has various applications, including environmental monitoring, food industry, detection of explosives, health monitoring. The best known application is the Breathalyzer. As driver breathes into the device, the amount of alcohol in their breath can be quantified. Every time we exhale, we release hundreds of different compounds in the air, which can reflect our health condition. If the level of particular compounds change, it could be an indicator of some diseases at the early stage. This can remind us to consult a doctor or to have detailed examination in the hospital. The key factor to detect the volatile compounds is the sensing materials. They should have several properties, such as high sensitivity to allow us to detect the low concentration of gas. Selective detection allows us to identify particular gas. To finally achieve their practical application, we should integrate them into the electronic devices in a scalable and efficient way. MOFs, as known as metal organic frameworks, are coordination compounds consisting of metal ions and organic linkers. They are assembled together to form 3D networks. MOFs are porous, with very high surface area. They are promising candidates for gas sensing. Unlike the non-porous materials, of which the chemical reaction can only happen on the surface of the material, the gas molecules can reach into the internal pores of MOFs, increasing the area of reaction, which means a higher sensitivity. The shape and function of the pores can be modified, which will only allow a particular type of gas molecules to get in. This can eliminate the influence of normal compounds in our decomposition, such as water and CO2, to achieve selective detection. Now, we can integrate several kinds of MOFs into the first generation of sensing chips through microfabrication techniques. It can achieve the detection of ethanol, methanol, and so on. Meanwhile, we are developing different kinds of MOFs to fabricate MOFs arrays on single chip to achieve wider and more precise gas sensing. Our final goal is to integrate gas sensing chips into electronic devices, such as cell phones. The development of e-notes has drawn particular attention nowadays under the global COVID pandemic. Most of us have experienced or maybe will experience the COVID test, which is not comfortable. Normally, they will insert a cotton swab deep into the nose or throat to extract some samples. But now, the breath test for the COVID has been reported, which is faster, cheaper, more efficient, and less painful. Luckily, We are not alone. Achieving the e-nodes needs the cooperation between material science and device engineering. There are several research groups and companies in the world are doing similar exploration. We believe in the very near future, we can achieve the portable health monitor on smartphones.